Alright, looking at your quadrilateral split book, this is page 34 in your notebook. We have one shape left, and it's squares. Squares. What? Remember what I talked about? Remember me saying that trapezoids and kites are quadrilaterals? Used to have to teach those. The state removed them from the standards, but I left it in the flip book because I feel like you should still know what a trapezoid is, but I'm not going to make you learn the properties, practice with it, or anything like that. So we're going to look at that page as, you know, here's a picture of one, here's what it looks like, but then we're moving on. All right. So squares. Open the flap so that you're looking at the information with squares. You will notice that it starts much like the last 3 days have, which is with properties of squares. The first 5 properties are the same properties as those of what shape?
Rectangle.
Parallelograms. Goes back to parallelograms. They all go back to parallelograms. So if you would right now, through a series of flipping your page, please, where's squares? Please go to the parallelograms properties, copy them to the squares properties, just the first 5. First 5. Okay, so at this point you should have the first 5 properties down. If you are falling asleep, please do everything you can to get uncomfortable and stay awake. In parallelograms and squares, opposite sides are parallel. Opposite sides are also congruent. Opposite angles are congruent. Consecutive angles are supplementary, which means what number? 180. Diagonals do what? Now, we have 5 more properties to fill in. They are the 5 properties of a rectangle and a rhombus combined. A square is the most complicated shape, and by complicated we mean, or I guess you could say bougie. It's extra, like it's got every property. Anything you can think of, it's got the property. Okay, so let's refresh your memory. From a rectangle, what do you know about the corner angles? They're all right angles. And what does the word right associate to what number?
90.
90 degrees. Also, like a rhombus, all sides are congruent. Also, like a rectangle, diagonals are congruent. also like a rhombus, diagonals are what to each other? Perpendicular. What angle measure is associated with perpendicular? That's that upside down capital T. To remind you, that's the notation. What's the angle though? 90 degrees. Perpendicular means intersects at a 90-degree angle. And then the last property of a rhombus is that diagonals bisect the opposite angles. That property holds true in a square. Okay, so there is a ton of information here on squares, right? We can't label all of that in our picture because then the picture is going to be overwhelming and confusing. So we're going to label the easy to forget properties, I guess you could say, or the ones that are the most challenging. Now, your picture already has that all four sides are congruent. That's already marked. And what are the four corners? Okay, I'm just going to put 90 on one of them because what we need to do is also mark that the diagonals, when they're drawn, are bisecting the opposite angles because that was a new property we learned yesterday, which is one of the more challenging properties to remember. So that's what we want to mark in the picture. So when we say that the diagonals bisect the opposite angles, okay, so first of all, remember that the opposite corner angles are congruent. Well, it's a square, so we'll take it a step further to say they're not only congruent, they measure what? 90, because it's a square. Okay, so if the diagonal is drawn, right, and it's bisecting a 90-degree angle, bisect means what, y'all? Cut in half. What is 90 cut in half? 45. So, a square, which I find the square to be the easier problem because it's every example is the same angle measure. That's what I like about squares. With a rhombus, a parallelogram, a rectangle, depending on like the length, right? Those angles on the inside change from problem to problem to problem. Not with a square. Not with a square. And the reason why is because when you take square and you draw the diagonals, they're bisecting 90-degree corner angles. 90 only cuts in half one way, and that's 45 and 45. Which means every picture of a square with diagonals drawn, where it's asking you about angles, you can go in and say, oh, okay, well, that's 45. That's 45. That's 45. 45. See where I'm going with this? What's this? 45. 45. 45. And 45. And what are the angles in the middle when the diagonals are drawn? 90 all around, right? So how many right triangles are in this picture? Like smaller ones. There's actually more than just... How many small right triangles, like puzzle pieces that come together and form the square?
4.
4, right?
Yeah, on each corner.
Yeah. And they're all what type of triangle? A right triangle. You can take it a step further.
Isosceles triangle.
There you go. Remember when I said however many congruent angles are in a triangle dictates the number of congruent sides. Well, if your triangle here is 45, 45, 90, that's the way you call it, then that means that this is congruent to this. And if it's because it's a square, where is it? Diagonals are congruent and diagonals bisect each other. That means all these pieces are the exact same. So, while a square is the bougie shape, it's got way too much going on. It's actually the easiest shape because in terms of angles, just angles, now the side lengths can change, right? You could have a 10, 10, 10, 10. you can have a 3, 3, 3, 3. So the side lengths can change. Diagonal lengths can change. But if we're talking about angle measures, they're the same every problem. You with me? Lost some of you. Right here, you know how I like to say, also look for, okay, I want you to make a note. Look for right isosceles triangles, and we're going to put in parentheses, or right next to it, 45 degrees, 45 degrees, 90 degrees. Because it's that way every time. Alright, we've covered the problems, the shapes, properties. Now we're going to go to the practice. Alright, look at example 1. If BCDE, so if this shape is a square, I would go in first of all and I would mark, okay, this is a square. I need to remind myself that I have a square here. And I would put maybe a right angle. You can do it on all the corners if you want, or you can put it on one corner. So that you just remember it is a square. It's not a rhombus. It's not a rectangle. It's a square. And then what's in the middle? 90. Just put 1 there so it doesn't get confusing. All right, now let's look and see what it asks for. Can't slide the thing over. All right. A says find segment CE. C to E. Right? No part of it's 8. Well, remember we said that in this picture, right here, the diagonals are equal to each other and they've been cut in half, so there's 4 equal pieces. All right. Now it says find BC. B to C. Don't know it. So we'll put a question mark here. Do I know this one? Look where I'm pointing. I'm pointing to BF.
Yeah, you know that.
I know this is 8. What shape is this?
Triangle.
It's a right triangle Pythagorean theorem. You've got a squared plus b squared equals c squared. Find the right angle and draw an arrow from the right angle to the side it's not touching. It's called opposite. That's the side we're finding. In this case, that would be the hypotenuse, right? So our legs, remember the legs of a right triangle are always the ones that form the right angle, or the L. Our legs are 8 and 8.
Equals.
It's going to be a decimal. We're just going to round to the nearest 10. 11.3. This ends up being 130 or 128. And then you square root that, and you get 11 point. I think 3. Right?
Yeah.
So I'm going to make note that this is 11.3. Now, it asks for 2 angle measures. I want you to try it first, and then we're going to answer it. Trace the angles, see if you can find them, state the measure, and then let's check it. Yeah.
We have to find the last two. The last two are safe. That's 90. Yeah.
87.
Where's that?
Wait, 90 is an angle measure then. 90 is never thrown into Pythagorean theorem unless it is the
Hey, what do you
other
get for
side.
Steve?
Remember what I'm- So you're blurring. Okay.
DB.
This one is probably a level 4 type question. We're kind of sticking more between levels 1 and 3, but I do like that question because once I show it to you, you're like, oh, that's actually not bad at all. But it's not going to be your test. All right.
Yeah, what do we have for lunch?
So angle CFD.
90.
90. Everybody should be able to answer this.
Yeah, it's 90.
Angle DBE.
45.
Guys, there's not a lot of angle questions on squares because it's boring because it's the same possible 2 answers every time. Which is why I like squares. I told you all that. I like squares because the angles are the same every one. Alright, so this was 90 and this is 45. Okay, we're going to do example 2. Although example 2 here is more degree of difficulty than we're really going towards, it's a good to know, it's a nice to know, it's not a must know. You with me? Number 1's a must know. Number 2 is, this is a nice to know, I'm going to show it to you, and hopefully it kind of helps you to be more intuitive with it, but you're not going to have to remember this for the test. Alright, so look at it. If QRST is a square, it says, mine's cut off here, it says find QS. So I'm going to draw a line on QS to remind myself, okay, this is the goal, right? I don't know it. I'm also going to go in and make marks that this is a square. Okay, so congruent, 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 congruent. This is 90. What is the middle again? 90. So if that's 21, what's this?
21.
What's this?
21.
All right. Now the goal is a diagonal, right? In previous problems, we've used one of these smaller right triangles that looks like a puzzle piece shoving together to form a square. Take your mind and expand it to this right triangle. So earlier when I said, how many right triangles do you see? And then I caught myself and I said, how many small right triangles do you see? The reason I adjusted my question was because there's actually way more than 4 right triangles in a square when the diagonals are drawn. Focus on the green one right here. How many sides do you know? 2. You know 2 of the green triangle, right? Of the green triangle. You know, that's 21, that's 21. You don't know the hypotenuse. It is the hypotenuse. That's the longer side. So set it up. A squared plus B squared equals C squared. What are the legs? 21 each. Yep. Ends up being 882, and you're square rooting that. So that's C, but it wasn't labeled C. What is it in the picture? It's QS. Okay.
It's probably like how far.
Okay. Okay. All right. Yeah, we're finished. That's all she wrote. All right. This is page 38. Much like the rhombus questions. Y'all want a delta map instead?
No.
Oh, what's that?
Hey, guys, look at it with only one side.
Thank you. It's the same concept, same approach, same layout, because they're all the same. Because, great question. So, this is in our video. Why are there some rhombi questions on the square problem?
Because they have the same properties.
Well, go back to what I said about a square.
All equal size.
The angles never change in a square, so there's really not a lot of practice questions on a square unless you're just talking about lengths. So that's why this worksheet has 2 rhombi questions thrown in there, because they're the ones that actually can change. All right, you have 11 practice problems The first two are just numbers, and not 11, I'm sorry. You have 6 practice problems. It starts with number 6. This feeds off of your rhombus worksheet. Rhombus was 1 through 5. This is 6 through 11. Yeah, this was technically the back, but I separated it. You have 6 practice questions. The first 2 are just numbers, and the last 4 are algebra. I want to see what you can do without me walking you through it every single time. I need to know where you're at. Okay? So please start working right now. We have until 11 o'clock. We have 15 minutes for 6 problems. I want you working by yourself at first, and then in a few minutes I will say now you can go sit with a partner and kind of check your work along the way if you want. Okay? By the way, this is 38?
Yes.
38? Does that sound right? Okay.